Hi, this is Mr. Manley. In this video, I'm going to take this expression and I'm going to express it in terms of an algebraic expression without any trigonometric operations or inverse trigonometric operations. So how do we do that? First of all, do we need to recall that if I had an expression like this, but with, say, a number, that we could evaluate this, right? I could say that the inverse sine of rad 2 over 2 is pi over 4. And then I could say that the cosecant of pi over 4 is 2 over rad 2. Rationalize the denominator, and I'd get rad 2. So hopefully you're familiar with a problem like that if you're watching this video. Well, how do we do that here? Well, maybe the answer is, well, let's look at another one. So what if I said the cosecant, let's not use sine, let's use, and what if I didn't have a convenient value? Like I just had rad 2 over 2, which is a convenient value that's on a unit circle. But say I had, I don't know, 17 over 4. Do you know what you would do with that? We would say that this is some angle theta. And I want to know what's the cosecant of that angle. And this angle here, which this is an angle, inverse cosine of 17 over 4. All right, I'm doing this backwards. I can't use 17 over 4. Let's go 4 over 17. That will work. Okay, so if I've got the inverse cosine of 4 over 17, that's some angle such that the adjacent over the hypotenuse, that's not a great scale there. Let's go up higher like that. Maybe that's a little bit closer. And so if I put the angle theta, which is this, so I'm calling this theta, okay? And if I put that into a right triangle, the adjacent over the hypotenuse would be 4 over 17. And then to find cosecant, well, we have to remember that cosecant of an angle, theta, is equal to r over y. Or if I'm in a right triangle, that would be the hypotenuse over the opposite side. So when I look at this angle theta and the opposite side here, which is what I need, I don't have the opposite side, but we can get that easily enough, right? I can say that the opposite side is equal to the square root of 17 squared minus 4 squared. And that is just a manipulation of the Pythagorean theorem, which I hope you can follow or take a few moments to reflect on and understand what we're doing. And then we would evaluate that, right? And we would find that the opposite side is rad 273, and that the cosecant of theta is the opposite, which is rad 273, over 17. So that's another type of problem that hopefully you're familiar with. Cosecant of the cosine, yes. So all of this is equal to rad 273 over 17. All right, so what's going on here? I don't have a convenient value. I don't even have a value. I have an x. Well, look at what I'm going to do with that. I'm going to say that this is theta. This is a theta. And that if I put that theta into a right triangle, since its inverse sine, that's an angle whose opposite over hypotenuse is x. Well, what would the hypotenuse be? 1. X over 1 is equal to x. And then let's also change this. Let's go back. Hopefully you won't object too much to this, but I don't want to do cosecant. Let's do tangent. The tangent of the inverse sine of x. So we know that for tangent, I need the y over the x. Or in a right triangle, it's that I need the opposite over the adjacent. Don't confuse these two x's, they're not the same. Okay, so but I need the opposite, and I've got it there. That's opposite. I also need, however, the adjacent, and that's there. And I don't have the adjacent. But we can find it by saying adjacent squared plus x squared is equal to 1. So the adjacent is equal to the square root of 1 minus x squared. There. So what's tangent of that angle? It is equal to the opposite, which is x, over the adjacent. And as always, let's rationalize the denominator. And we will end up with x rad 1 minus x squared over 1 minus x squared. All right, let's take a look at another one. All right, so here we'll change it up from tangent to cotangent and from sine to cosine. These are always what we're going to give you or what you're going to get. It's always going to be in terms of x. It's always going to be evaluating x. So if this angle were in a right triangle, it would be the adjacent is x. There's theta, and the hypotenuse is 1. And then this side would be the square root of 1 minus x squared. And then the cotangent is adjacent, which is x, over the opposite. Hey, and that's just the same as the one that we just looked at, right? Different functions, same result. Okay, so that's something that will probably come up, definitely come up for you in pre-calculus, and will probably come up in calculus as well, working with expressions in this way. Okay.